Welcome, everybody. Thank you for joining today's webinar, Choosing the Ideal Safety Solution for Your Burner Management System, co-hosted by ISA and Honeywell. My name is Michaela Cooper, and I'm with ISA, and I will be hosting today's webinar. Before we get started, I would like to review a few housekeeping items and let you know how you can participate in today's session. First, for questions, please feel free to submit your questions at any time throughout the webinar.
I'm sorry, we can barely hear. Is there any way to make this louder?
Are you listening in through the phone line or on the computer?
The phone line.
Okay. We are not opening up the phone line, so if you have a question, if you could just submit that through the chat toolbox, that would be great. Okay. So just to reiterate what I said, we are not opening up the phone lines for any questions. If you are experiencing any technical difficulties, then please just contact me directly using the chat toolbox. So we will have two Q&A sessions, one after the first portion of the webinar and one Q&A session at the end. If we are unable to get to your question during the first Q&A session, we will hold your question till the final Q&A session. To submit your questions, simply type them into the chat toolbox on the right-hand side of your screen and send them into me, Michaela Cooper. If you are viewing along with others at your site, please designate a scribe to submit your group's questions. And unfortunately, with almost 300 pre-registrants, we cannot open up the phone lines for questions. If we do not get a chance to respond to your question, or if you would like to discuss a topic in more detail with the presenters, feel free to contact them directly, and their contact information will be given at the end of the webinar. Second, keep in mind that if you are listening in through your computer, the quality will not be as clear as listening through your phone. So if you have the option to dial in to the phone line, I'd suggest doing so. And for those of you who just joined, please make sure that you are on mute. Both your computer and your phone microphone should be on mute. This is not an open webinar, and we will be not opening up the phone lines. If you would like to see the phone and VoIP connection instructions again, please refer to the confirmation email I sent to you today, or if you go to the top left-hand side of your WebEx screen, you will see a tab labeled Meeting Info, and the connection instructions are included in there. Okay, I think that takes care of our housekeeping matters. Let's go ahead and get started. Jerry, I'd like you to go ahead and take it from here.
Hello, my name is Jerry Gilman. I'm retired from Procter & Gamble Company after 37 years of service. I was a P&G coordinator and resource for safety instrumented systems and safety standards. That is, I would keep in touch with the different standard committees and groups and make sure that our technical writers could upgrade our documents for our in-house standards as needed. I was a control systems engineer in numerous business categories. I designed boiler control systems and performed numerous boiler startups. I also was a key resource to people if they had problems with their computers, in particular their control or burner management systems. I'm a registered professional engineer and a fellow life member of ISA. I'm a course developer and instructor for ISA. I developed the courses Boiler Control Systems Engineering and Burner Management Systems Engineering. I'm an instructor for both courses. I'm a member of ISA 84 committee that developed the standard for applications of safety instrumented systems for the process industries. I am a member of ISA 77 standards committees that develop standards for fossil fuel power plant facilities. I'm a member of the NFPA, that's the National Fire Prevention Association. I'm a voting member on that committee of NFPA 85 code. and that code is the Boiler and Combustion Systems Hazardous Code. I'm a voting member on the single burner code, but I also participate in all the meetings of the multiple burner code. I have a book titled Control Systems Engineering.
Good morning, good afternoon, good evening to everyone across the globe. My name is Praveen Jose. I am currently working with Honeywell International. I'm very glad to be presenting this webinar with Jerry Gelman. A little bit about myself. I have a MBA from HBU in Houston and a Master of Science in Chemical Engineering from Texas A&M at Kingsville. I'm a certified product manager with AIPMM and also TUB certified as a functional safety engineer. I have around 8+ years of progressive experience, which include engineering, project management, product marketing and development. And I currently have a global responsibility of 2 products within the Honeywell portfolio, which is HC900 and Experion HS. That's a little bit about me. Okay. So now I would like to speak a few words about Honeywell. Honeywell Process Solutions has been a pioneer in industrial automation control for more than 30 years. And we have more than 30,000 installations in over 8,000 sites globally. Honeywell's expertise and innovation help industries around the world perform more efficiently, protect the environment, and keep people and assets safe and secure. We are present in more than 100 countries, and we serve many industries, including refining, oil and gas, paper and printing, power generation, chemicals, life sciences and metals, minerals and mining as well.
The agenda for today will be covered by both myself and Praveen. My part of it will be discussed, talk about what is a burner management system, the causes of boiler explosions, and some of the requirements for the safety control systems as defined by NFPA code. It will be followed by the first question and answer session, which will be session 1. Then after I have completed my session, Praveen will talk about more about what is an SIS system, what's that mean, addressing the challenge, and talk about the ideal solutions. After that session is finished, there'll be another Q&A. As was commented at that time, we'll do our best to answer the questions, but it was stated with this many people involved, it may be hard to cover all the questions that we may have. You will be given information how to contact us afterwards if you need to have any further issues addressed. As an introduction to what we're going to be talking about and what brought around many of the things that are explained today in industry, that was due to numerous explosions and fires in plants and around the world and in the U.S., it was decided to develop ISA 84, a standard for defining the requirements of the PLC logic system. And it was done in 1984. Initially, it was to define the needs for the logic system and a systems solver, but when the committee quickly decided we need to include both the inputs and final elements. This will also be addressed by Praveen. ISA 84 is also ANSI, ANSI, American National Standards Institute. It defines the requirements for safety instrument and systems for the process industries and NFPA boiler. NFPA 85 Boiler and Combustion Hazards Code defines requirements for boilers. The IEC developed a standard logic solver, which is IE 61508. This defines the requirements of your logic system or process, your equipment for solving and handling issues for safety. This has been accepted as a world standard. The IEC also developed a standard for the safety instrument and systems, which is IEC 61511. In 2004, ISA updated their system and was modified to agree with IE 61511. So this is a worldwide standard. Okay, first of all, I'm going to talk a little bit about the function of the safety system. It's to reduce likelihood or mitigate consequences in the event that you have an issue with your system. For example, if something should go wrong, it should address and manage that problem within that condition. It monitors and controls the process. It compares these values to safe values. If the condition is unsafe, and you may go to an intermediate state, systems go to a safe state. And I want to emphasize this point that going to a safe state is very important rather than going to a shutdown. If possible, it's good to keep systems running because it seems that most incidents occur on restart after shutdown. Shutdown systems isolate the process, prevent startup if a problem is not fixed, and require manual reset before a process can be restarted. In other words, make sure the system is corrected before you try and start again. The burner management system is a system monitored to control the fuel burning equipment. It presents the operator in a concise format and it innate safe operating conditions. Cause of explosions. There's many things that will cause an explosion, as I will address and discuss further on. One of the main reasons for explosions is operator error, but I will discuss and cover those in more detail in just a moment as I talk through these systems right now. That's improper procedures by operating personnel, improper design of equipment, improper design of control system, inadequate air purging, interruption of fuel supply or air supply, or then introduce them in an incorrect manner, so you'll end up with a fuel-rich mixture that will cause an explosion. Fuel leakage into an idle furnace can also create an explosion, particularly if there are hot spots in the system, or if they need to try and start an ignition and there's fuel-rich system in the boiler, you can create an explosion. Repeated unsuccessful attempts to light off. This has been a real common problem in the industry where people and their operators cannot get the system to light off, and they keep trying and trying again until they have an explosion. If you cannot solve the problem, you need to shut down and determine what the problem is before you try and start up again. These next slides really talk a little bit about some of the reasons that this particular insurance company had input and had to pay for some repairs or whatever it may take as far as they're concerned. You'll note on there I've asterisked by a number of the items. These represent really pure human error or interface problems. Low water cutoff was by far the most, with 44 for low water cutoff. That is, people did not shut the boiler down when the water got low and would eventually cause rupture of tubes or some other damage to the system. Operator error, there were 34 incidents reported to the insurance company due to operator error. Improper installation, and the system may not have been put in as according to the design and the design requirements. Burner, that was 8. Burner failure is 6. Faulty design, there was just 3 there, but then that again can be very key. Limit controls. The controls were limited and did not give enough detail or operate properly. Improper repair, there were 2. In other words, there was a repair to be done, but it was not done properly. There's less than one more safety valve failure. That'd be your relief valves. Other contributing factors were lack of operator attention. That was 11. Again, that gets into the problems with some of your operators and not paying attention. Lack of training and supervision was 7. Accidental misoperation was 1. Operating in poor conditions was 5. Operating in known poor conditions is 5. And malicious misoperation was 1. So a total of 30 items in this 1 year was reported as problems and resulted in payments by the insurance company. Other contributing factors, the recommendations were not completed. In other words, they were recommended to fix a problem, or they knew of a problem but did not complete or do the repair. Testing inspection not performed. In other words, they were supposed to say they're testing at least once a year, which is very common, but it was not done. So when there was a problem, the system did not go to safe state or shut down. Routine maintenance not performed. So under this contributing factors, we have 37. So very simply put, when fuel and air are proportionally mixed and an ignition source is applied, if controlled, you have combustion. In other words, if you have good fuel-air mixture in the right proportion, you're going to have combustion. If the mix is not the proper proportion, or if not controlled, you're going to have an explosion. So at any time you have the air or fuel or igniter come in the wrong sequence, you're going to have an explosion, or because they're definitely have an explosion. Now, some people say a puff is not an explosion because it did not do enough damage to shut down or prevent the system from running, but it still is an explosion. This is going to be a few slides showing them explosions and some of the conditions of these explosions. The ignition of a combustion mixture within the combined space of the furnace or associated passes, ducts, and fans that convey the gas of the combustion to the stack. Statistics indicate, as I just pointed out, human error is a contributing factor in the majority of the explosions. This picture right here was in 1910. However, I was at the company that owned this boiler, and they weren't sure what happened, but they was pretty sure it was a gas explosion. Gas explosions will tend to do a lot more damage than some other types of explosions, such as coal dust or something like that. But gas explosions do a great deal of damage, and many people are killed in the result of a gas explosion. This next one is a case of the fuel mixture got rich. It was in the duct work. And when they tried to light off, they got the fuel going in before the air came in. And when the fuel started coming in, and then the igniter came on, and had an explosion. So they had a fuel-rich mixture in the duct work. So that's what this picture covers, that explosion in the duct work. This is a real bad but good example of operator not doing what they were trained or trying to bypass the system. This is a particular boiler. It's a brand new boiler, had not been continuously put into operation. The two operators were trying to light off after a shutdown. Again, this is after a shutdown. They were trying to light off again. They could not get the system to light off. They went and took the locks and pads off of the manual shut-off valves and opened those valves and opened the control valve. When they did, they got a very fuel-rich mixture going into the boiler, and the heat that was already in the boiler from the previous ignition of the boiler caused an explosion. And it did a tremendous amount of damage, as you can see in this next video. This next picture. Unfortunately, both of the operators were killed in this incident. So there are a number of organizations that are involved in the standards, living up to the standards and making standards. Certainly our plant owners need to be aware of the standards and requirements, whether it be something they have to do with ISA 84 or FPA code. Insurance companies certainly always interested, and most of them require either an FPA code 85 or some other system for checking and making sure you have the right systems required for protection. System manufacturers, such as Honeywell, are always want to know what they are and try to keep their systems up to date and meet all the requirements. Independent certification laboratories or bureaus make sure that they are available, and whatever system you have is checked and tested as satisfactory or labeled for the process you're using. Government agencies are always involved. Now in the United States, it's the OSHA organization, which is Ohio Safety and Health Association. Now I'm going to talk a little bit, but this is far from a lot of it in there, but I'm going to talk a little bit about your programmable controller guidelines or logic solver, whatever you may call it. Diagnostics shall be included in the design to monitor process and logic function. This is a problem that some of your lower cost systems do not address. They do not have the built-in diagnostics that you need. The logic system should not preclude proper interface. Logic shall be protected from unauthorized changes. Logic shall not be changed while the associated equipment is in operation. System response time, or that's the throughput of the logic system, shall be short to prevent negative effects on the application. Protection from the effects of noise shall prevent false operation. That also can be noise from not only the circuitry, but also perhaps using walkie-talkies or some other device that may cause a problem in the safety system. In other words, no single element or component within the logic system prevent a mandatory master fuel trip. In other words, you cannot have any kind of bypass in there that will keep you from going into fuel trip if you have a problem. So no fuel trip can be bypassed. The other thing that's become a real big issue in the industry is the independence of your control system and your safety system, whether it be burner management or any other process control safety system. Except as noted in the burner management system shall be provided with independent logic solving hardware, input-output systems, independent power supplies, and shall be functionally and physically separate. For single burner boilers, the control system shall be permitted to be controlled with the burner management system under one of the following conditions. In other words, under most conditions, they need to be totally independent. But under a couple of conditions, you do not have to keep them independent, but they can be built into one system, provided it meets the safety requirements. If the fuel air ratio is controlled externally from the boiler control system, and if the combined boiler control burner is specifically listed and labeled for that particular application. Now that's still being discussed, even though this is a requirement for independence, is even if it's labeled, you need to be careful that your control system and your safety system have an interaction that can prevent going to a safe state or a shutdown. This is an example of a mechanical system whereby you can see that you got your master controller, your fuel valves and air are mechanically adjusted. In this particular case, they can be combined, so this is an example of an external control system. So the requirement for independent network communication between the burner system and the system shall be permitted. In other words, you can have communications between the two systems, but it's necessary to make sure that all your signals go directly to the burner manager or your safety system, and then you can bring that system over to control, but not from the control system to the burner management across the highway. That's not permitted. So initiate mandatory master fuel trip shall be hardwired. Some refer to this as direct wired. In other words, go from a push button or shutdown directly to the shutdown relays. The logic system shall be limited to one boiler or heat recovery steam generator. In other words, each boiler or type of boiler must have its independent logic system. The same hardware type used for burner management system shall be permitted to be used for other logic systems. In other words, you can use the exactly same system for control and burner management, but they need to be two separate systems. You can use the same ones as long as they meet the requirements. This is a little bit more about requirement for independence. The mandatory master fuel trip sensing elements and circuits shall be independent of all other control systems. A little bit is a repeat, but it's a highlighted under multiple burner boilers. Individual burner flame detector all shall be permitted to be used for initiating master fuel trip systems. Airflow and auctioneer furnace draft analysis from the boiler control system shall be permitted to be used for a master fuel trip provided all the following conditions are met. The interlocks are hardwired in the burner management system, which is what I just talked about. Tripping of the points are protected from unauthorized changes. Any single component failure in the sensing elements and circuits does not prevent master fuel trip. Now, when they did a revision of the IEC 61511, which is the IS 84, when that revision was made in 2004, it did not require a shutdown. This is what it says in there. A safety instrument system is normally separated from the control system for the following reasons: to reduce the effects of control in the safety system, especially when they share common equipment. For example, if the control system and safety system share a common value for shutdown in control, then the event of a dangerous failure of that value, it would not be available to perform safety shutdown functions. To retain flexibility for changes, maintenance, and testing, documentation related to the basic process control system. Physical separation between control and safety systems may not be necessary, provided independence is maintained and the equipment arrangements and the procedures applied ensure the safety system will not be dangerously affected. It's important to be able to document failures of the control system and work carried out on the control system. For example, maintenance of operation. Any work on the control system will not affect the safety system, or safety management system, or the burner management system, whenever it's defined. So all this is controlled by interlocks, a device or arrangement of devices in which the operation of one part or one mechanism of the device arrangement controls the operation of any part of another mechanism. In other words, if one of these devices should sense a fault, it would go to a safe state or to a shutdown state. And typically, fail-safe is considered de-energized the trip. Any questions at this time?
Okay, great. Thanks, Jerry. So at this time, we'd like to move into our first Q&A portion of this webinar. We've already received some good questions, and I encourage you to join the discussion and submit your questions using the chat toolbox on the right-hand side of your screen and submit them to me, Michaela Cooper. If we are unable to get to your question during this Q&A session, then we will hold them till the final Q&A session at the end. So to begin, the first question asked, and everybody please forgive me, I am in marketing and and not too technically sound in this area, so please forgive me if I mispronounce anything. The SIS is shown to be in parallel to the BPCS. How does this ensure that the operation of the BPCS is safe?
Well, this depends on the type of the setup of the system. As I briefly mentioned, you have to make sure that any systems that go into your safe shutdown, in other words, your safety instrument system or your burner management system, is completely independent, so that no signal can come from the basic control and go across the line to the control to the safety system and cause a shutdown. All shutdowns need to be handled through the safety system or the burner management system. And so it's very important that any outputs from the control system do not go across and accidentally shut down the control system. I hope this answers the question.
Great, thanks. Our next question is, NFPA 85 applies to boilers only. Section 1.1.3 states, this code does not cover process heaters used in chemical and petroleum manufacture in which steam generation is incidental to the operation of a processing system. What standard should be used for furnaces/burners that are not boilers?
NFPA 86 is one, and also NFPA 87. Heaters are covered under 87.
Okay, great. Next question. Which particular code and clause requires one logic solver per boiler?
It's in the NFPA code. It's part of the definitions in NFPA code 85.
Basing from B149.3 code, do you recommend to install a separate BMS and separate BPCS if a small oil and gas site is unmanned and the site is worth $100,000 only? The unmanned site is monitored by remote operator.
This has always been an item under discussion, and Rafin will get into what we call the safety integrity levels. It's generally considered that in the particular case where people may not get injured or hurt because it's a remote location, operations are from a remote location, and if there is damage done, it's not significant. For example, if you have, say, 2 or 3 remote boilers and one of them shut down, it's not going to hamper your process. In this particular case, you're okay.
Okay, great. Next question. I've heard that PLCs, specifically listed for combustion service, do not exist yet. Is this true?
They're not specifically listed for combustion servers. They're listed for safety applications, and some of them are given SIL level to their system. For example, some of them are listed for SIL 2, which is generally acceptable for boiler operation as SIL Level 2. Praveen will talk a little bit more about it as he gets into it. Does that answer? Repeat that question again, make sure I answered it properly.
Yes. I've heard that PLCs, specifically listed for a combustion service, do not exist yet. Is this true?
Yes, they're not. They are not, and they won't be. They're all listed for safety applications, and they're either labeled or agreed to. None of them specifically state for burner management for the simple reason they want them to be used for all safety applications, whether it's burner management or not. So as long as it's labeled and approved for safety applications, it can be used for burner management systems.
Great. Next question. Is it appropriate and possible to design automatic BMS involving no/minimal human intervention?
Well, you always have to have the human intervention. In the case of an emergency, you have emergency push buttons to shut the process down. Otherwise, it's very common that particularly in smaller systems and in plants and office buildings, there's no operator intervention. It's all done through just a start button, starts up and runs by itself. But in any case, in any boiler, you do have to have some way of manually shutting the system down if there's an incident discovered and it's not shut down or it's go to a safe state automatically.
Great, thanks. We'll just keep rolling through these questions here. We've got quite a number of them, but after a few minutes here, we'll stop and turn the time over to Praveen. Okay, so next question asks, are boiler manufacturers obligated to notify the purchaser if their requests result in a violation of NFPA code?
There's no actual requirement that I know of legally. However, I think it would be very poor practice if they didn't do that. I can't imagine any boiler manufacturer having any violations in there that would not meet 85 code. All boiler manufacturers are very careful in trying to meet the NFPA 85 code. The committee, just to help you understand that, consists of boiler manufacturers, engineering contractors, plants, independent, what they call experts, which is the category I fall under. So I think it's very safe to say that all boiler manufacturers try to make sure they meet the NFPA code requirements for their systems.
All right. Thank you. Next question. Logic solver OEMs have developed a logic solver that contains software that can control SIS, safety interlock and flame monitoring, and BPCS combustion control in one hardware package. Is this recommended?
At this time, it is not recommended unless you have a mechanical process linkage towards fuel-air mixture on boilers, as I pointed out in my talk. That's under highly discussion. We are, on the SPA committee, we're very much aware that many companies are coming out with this type of system. But at this time, it still needs to be independent as far as the NFPA code goes. But as I said earlier, the S84 code does not necessarily say you need to do it. They're just saying it's a nice thing to do, etc.
All right, great, thanks. Our next question asks, what is the definition of a manual reset for ISA 84? Must it be in the field, or can it be done electronically in the control room?
Typically expected to be done in the field. The reason for it to be done in the field is that the person goes out to the field device and make sure they understand what caused the problem so that they can correct the problem and reset it locally. In other words, if it trips, it won't reset if the condition goes back to normal. The only way you can be sure of that is go out to the device. Some companies may go ahead and allow reset manually. For example, a low water trip. If you have a low water trip, you're not, other than looking in your site class, those can be reset from the control room. But most other ones, it may be a good idea to go out and look and really take a look and see what the problem is to make sure that the problem is corrected or adhered to before you start back up again.
Okay, thank you. Next question. Is it recommended to bypass any SIS protection in any situation with certain precautions?
I'd have to look really close at the code. Under no conditions are you normally permitted to bypass any of your safety interlocks during normal operation. In other words, your safety shutdown, your safety alarms. However, the company I was with, we did get permission to buy those so we could do testing online. But when you do testing online, you have to alert the operator that that particular device is out of service for a short period of time. And while it is out of the service, they're aware of it, so they got some other protection, such as going to the manual shutdown. Now, the way we did this, they would go to the local device, press the test, and the timer would start that the test is in process, so that if there is an event that would cause that to go to a shutdown or safe position, it wouldn't operate. Usually about 10 seconds before the test time is up, a light will flash alerting them that if they don't get back to the normal state, they will go to shutdown. But as long as it's documented and you have some kind of safe way of doing it, and in some cases you can bypass during normal operation. At least we were given permission at our company and the way I just described. But the operator always had to be aware that that item was not in service at that particular time, and it has to be noted in the logbook.
All right, thank you. Next question. If a BMA has already a flame detector, can we remove low fuel gas strip?
What's that question again?
If a BMA has already a flame detector, can we remove low fuel gas strip?
Not according to NFPA. You have to have a low gas trip, and the reason for the low gas trip is because if your gas gets too low and you don't have sufficient gas for air, your flame will be very unstable.
Okay, next question. To your experiences, what is the minimum and maximum SILs with a manned onshore BMS?
Well, as I pointed out earlier, safety integrity levels, again, which will be addressed more by Praveen. For most boilers, you consider all the items that are required by the NFPA code to be safety integrity level 2. That's kind of my rule of thumb that we used at P&G, and I think generally in the industry that's pretty well accepted. I would hope Praveen will address that a little bit as he talks about it.
Okay, great. Thank you, Jerry. We've got a lot more questions, but unfortunately, this is kind of one of the shorter Q&A sessions, and we'll hold everybody else's questions to the end. So thank you for submitting it, and you can continue submitting questions also throughout Praveen's presentation. So we're going to go ahead and turn it over to Praveen, and he's going to take it.
Thank you so much, Jerry and Michaela. It was a very informative first session. I have a few other topics to cover as I move through this presentation. And one of the first things that I wanted to talk about was the layer of protection. The layer of protection, or LOPA as it is called, consists of various layers as outlined in the picture right in front of you. The layer of protection consists of various independent protection layers that are capable of performing its actions on its own. So here you see a process design, and then the basic controls, the process alarms. Then you've got the critical alarms and the automatic action of the safety system. These all fall under the protective layers. And then you've got various other independent protective layers, which are especially for mitigation, which are the physical protection, relief devices, dikes, and the planned emergency response. So each IPL is capable of detecting and preventing or mitigating the consequences of specified potentially hazardous events, such as probably a runaway reaction or a loss of containment or an explosion. So the layer of protection can actually be used at any point in the life cycle of a project or process, but it is most cost-effective when implemented during front-end loading, when process flow diagrams are complete and the PIDs are under development. So for existing processes, a layer of protection or LOPA should be used during or after the HAZOP review or the revalidation. The LOPA is typically applied after a qualitative hazard analysis has been completed, which provides the LOPA team with a listing of hazard scenarios with associated consequences, with the description and the potential safeguards for consideration. So, after having spoken about the LOPA, let's talk a bit about functional safety. What is functional safety? So, functional safety, Jerry had touched upon this, but as it's defined by the IEC standard 61508, it is the safety that control systems provide to an overall process or plant. So the concept of functional safety was developed in response to the growing need for improved confidence in safety systems and major accidents around the world, as well as the increasing use of electrical, electronic, or programmable electronic systems to carry out safety functions. And during some of these dangerous failures or the need to control them, industry experts began to address functional safety and formalize an approach for reducing risk in the process plant environment through the development of various standards like the ones that Jerry mentioned, the 61508 or 61511 or the ISA 84. So previous safety standards were generally prescriptive in nature and not performance-based, and an emphasis on quantitative risk reduction, life cycle considerations and general practices make these standards different from their predecessors. So in short, functional safety is a term that's used to describe the safety system that's dependent on the correct functioning of the logic solver, the sensors, and final elements to achieve a desired risk reduction level. Functional safety is achieved when every safety function is successfully carried out and the process risk is reduced to the desired level. Now, let's talk a bit about what is a SIS. So, there was a question previously asked where they saw a safety system and a BPCS, which is side by side to one another. Where this is exactly the same diagram where you see a process vessel with temperature transmitters and pressure transmitters in blue, with power and CPU and inputs and outputs all in blue. But then you also have a safety system on the left, even though it looks like a parallel system. But what the safety system is doing is that it has got a separate PLC or a separate independent system, which is also monitoring, some of the pressure and the temperature parameters. So when the basic process control system controlling the processes has got all of these sensors tied to the control, the sensors tied into the process. So in this particular process, if the basic process control system is not able to control the process parameters, that's when the safety system also looks at those parameters and decides to take an action and decides to bring the process to a safe state because the process is currently in a pretty dangerous state, and it needs to bring and shut down your whole plant in a very safe and acceptable manner, so that it does not cause any accidents or explosions or damage to the environment, to people out there. So that's basically the job of the safety instrumented system over here, where it acts upon in case of a dangerous condition where a process value really exceeds the set point or the normal operating conditions. So let's look a bit about the role of a SIS further. So in this particular diagram, you would see a normal behavior where you have a process layer on the bottom, with the basic process control system in the process control layer. So if If a process is operating in a normal way, you would obviously see your PV parameters, within the process control layer. But if your process parameters exceed above a certain value, that's where you see a process alarm, and it goes into the next step where the operator has to intervene. And if the operator intervenes and brings the process back into control, well, then you don't need to go into the next level, which is the safety instrumented system, where the SIS comes in and prevents any kind of incident over there and brings your process back to a safe state. So this diagram actually explains a bit more on the role of a SIS when there is a process alarm and when your process parameters actually exceed the normal operating conditions. So let's look at the relation between SIS, SIF, which is a safety instrumented function, and SIL, which is a safety integrity level. So in this particular diagram, on the right side, you see something which is called as an SIF, the safety instrumented function. So the SIF, basically consists of a sensor, a logic solver, and a valve. So a SIF, sensor, logic solver, and final elements act in concert to detect a hazard and bring the process to a safe state. Like the safety features on an automobile, a SIF may operate continuously like a car's steering or intermittently like a car's airbag. And the safety function operating in the demand mode is only performed, when required. So if you look at this diagram, you'll see that a SIS will contain multiple SIFs, and each SIF would have a separate SIL level. So this is one safety instrumented system on the left, and you have multiple SIFs that are identified, multiple safety integrated functions, and each SIF would obviously have a safety system, a sensor, and a valve, and that sensor, safety system, and valve would have a particular SIL rating. And then you would identify multiple SIFs like those where each of it would have a separate SIL rating. So you could very well have a complete safety instrumented system with 3 different systems with a SIL 1, SIL 2, and a SIL 3 level. So it's very, very important to understand that a SIL level actually is not assigned just to the safety system, but it includes the sensors, the final control elements, and the PLC, or the programmable electronic system, or the programmable controller, whatever you would like to call it. Now let's, when determining whether a SIL 1, SIL 2, or SIL 3 system is needed, the first step always is to conduct a process hazard analysis to determine the functional safety need and identify the tolerable risk level. Now, for some of the for the boilers, as Jerry mentioned, most of the times it is SIL 2 as defined by ISA 84. But I'm talking about maybe safety systems which are outside a boiler too, where a hazard analysis is usually the first step. Now, after all of the risk reduction and mitigation impacts from the basic process control system and other layers of protection are taken into account, a user must then compare the residual risk against the risk tolerance. And so if there's still an unacceptably high level of risk, then a risk reduction factor is required. So if you look at this diagram on the right, you will see that there is a particular risk that is there in your process. There is an acceptable risk as well, and there is an actual risk after doing a hazard analysis. So the difference between your actual risk and your acceptable risk is the amount of risk that needs to be reduced for your particular process. So now, suppose you find out that your risk reduction factor is between 10 and 100. So if you look at the bottom right figure, you see that if your risk reduction factor is between 10 and 100, then for that particular SIF, you remember that a SIF is your safety system, your valve, and your final control element. For that particular SIF, your SIL level would be 1. But then if you find out that you actually need to reduce a lot more risk and your risk reduction factor is between 100 and 1000, then your safety integrity level would be SIL 2, and so on. So you have various SIL levels over here, as you see. It's from SIL 1, SIL 2, SIL 3, SIL 4, where SIL 4 usually indicates that it's for operations usually which involve maybe a nuclear process. But SIL 3 would be probably a lesser complicated one, where most of the oil and gas and refinery they require SIL 3. So this is how a SIL or a safety integrity level is determined after a proper hazard analysis is done. So it's very important to really find out what your risk is and what kind of system with what kind of SIL level is required for your particular process. So there is no standard rule which says that you would always have either a SIL 1 or a SIL 2 or a SIL 3. It can differ based on the existing design of your basic process control system as well. Now let's look at a safety programmable electronic system versus a general PES. So we obviously cannot use a conventional PLC to perform safety functions. Now, mainly because of the lack of fault tolerance and the fail-safe capabilities. A logic solver or safety PLC is specifically designed to accomplish two important objectives. The first one is it should not fail, and it should have redundancy that works well. But then if that cannot be avoided, it must fail only in a predictable, safe way. Now this goes exactly to the point that Jerry was mentioning as well, that a safety system, the main job of a safety system is to bring your process to a safe state. So it's not to shut it down, but to shut it down in a safe state. And a safety PLC as compared, or a safety PES as compared to a general PES, has got a lot of other features as well, such as fault tolerance, fail-safe capabilities, advanced diagnostics. They also have redundancy at CPU power supplies and communication levels, it can communicate easily with third-party PLCs, and you can have multiple burners and multiple scanners, and a lot of additional features are capable through a safety programmable electronic system as compared to a general PES, which is not designed for such tasks. So let's see how we can address some of the challenges that are there in the industry, along with the process control and also for safety as well, and how we address this challenge. So now when we go into the market, you're looking for the right process and safety system. We need to make sure that we're looking at a product that's proven and reliable in the field. We're obviously looking for something that has thousands of installations globally to ensure that they're experienced players in the market. So that's one of the things. The product that you're looking for should be proven and reliable. You're also looking for a product that's fault tolerant as well, and we'll be looking at a system which has redundancy in at least at CPU racks, power supply, and communication level that allows customers to keep their systems running continuously. So we're looking at a system that provides also capabilities to do online configuration, monitoring, removal and insertion under power, and because during startup a lot of time can be spent tweaking the design or correcting design mistakes. So this is another key aspect when you look at process and safety system. Obviously, diagnostics. Myself and Jerry, we both touched upon it, that the safety system that you're looking at, or the process and safety system, should have advanced diagnostics at module and channel level that adds reliability to the system. And we also need a system that provides with advanced sensor diagnostics, allowing operators to detect unforeseen incidents, thus maintaining a safe and continuous operating environment. It would also be good if you have a system which has the ability to provide a backfill functionality within the system that allows your HMI to search back into the controller database and backfill the information if communication is lost between the HMI and the controller. Obviously, easy to use process-specific blocks or engineering tools that would meet various application needs, thus reducing engineering costs. Customers many times with a 500 to 800 I/O system can save around 10 to 15% of their engineering time. And you would also be looking at a system which is modular and easily scalable, so that you can easily expand as the process expands. And you will also be looking for quick application startup time and online editing as well. So ease of engineering and capability to expand is a key aspect, along with some of the other aspects in easy integration. So as you look at to address the various challenges that are in the industry, you would also want your system to be easy in all the aspects, such as easy to integrate with third-party PLCs, because there are so many out there now, with other HMIs and other devices. You would also want easy product enhancements and low-cost upgrades as well, because your total cost of ownership would always be under question too. So along with all of these, you are also looking at a system that can provide you with high performance, that can provide you with tighter control, that prevents process overshoots, and increases your throughput and efficiency, which reduces your scrap as well. And so this is a key aspect too when you look at looking for a solution out there. Process and safety. When you look for an efficient process and safety system, you're also looking for common tools to reduce engineering and training costs. It's always advisable to partner with someone who has a complete portfolio, and as I mentioned earlier, also a proven track record. You would obviously want to see that the system you use are not self-certified by the vendor himself, but obviously by an external agency, so that there's added validation, ensuring safety out there. So let's now take a look at an ideal solution that can help some of these choices you would have to consider before selecting a process and safety system or a burner management system. So what you're looking at over here, you're looking at an HC 900 process and safety system. This architecture provides a snapshot of two separate systems, one of which is a safety system on the left and other a process control system on the same network, but they are segregated as two separate systems. Now this is the best part of the HC 900 system now, that can be used as a process control system and also a safety system. The HC 900 safety system is undergoing the SIL 2 safety certification and will be capable of being used in a SIL 2 safety environment. So in the end, you would have a single flexible system for safety and process control with faster startup time, common engineering tools, reduced training, simplified maintenance, and lowest cost of ownership. Now, when you look at this diagram, this just shows the advanced capability of the system, where our HC 900 system would allow safety IOs and non-safety IOs as well within the same architecture. So there is provision within the software that allows a process worksheet and a safety worksheet too. And programming is possible depending on your application needs, and the process information is totally non-interfering with safety data. So there is no exchange of information between process and safety because it's totally restricted. And even though we have this provision within HC 900, you would see many standards asking for total independence, not only within software but also within the hardware, which means they, like Jerry was mentioning, they would ask you to have separate hardware and software for process and safety applications. But nevertheless, this feature is available within HC 900, where we are looking to integrate a few process points, just doing monitoring over there, and that prevents a need to avoid a separate process controller for the same. So having said that, I would like to conclude that HC 900 is a proven and reliable product that will help you maximize your uptime. It's easy to use and engineer, thus lowering your operational cost, with the easy startup, product upgrade and maintenance fees as well. It is a very efficient product, providing you with tighter control, reducing scrap, and thus increasing your profitability. Lastly, this product from Honeywell can provide you with enhanced safety, as it can provide you with a process and safety on the same platform. It will surely provide value for your money, and now with the new TUE SIL 2 certification, which will be achieved soon, we'll be able to target additional applications which require a safety PLC, which is capable of being used in a SIL 2 environment. So having said that, I would like to conclude my presentation and hand it back to Michaela to address any additional questions that might be there.
Thank you, Praveen. That was wonderful. Thank you. so before we jump into our Q&A session here, I'd like to remind everybody that Automation Week is next week in Nashville, Tennessee. And on behalf of Honeywell, they are giving all those listeners today 20% off their Automation Week registration fees using the promo code shown. It is P12349FJ. So using that promo code, you can receive 20% off Automation Week. Register today, and time's running short, so register as soon as you can. And if you miss writing down this promo code, I'll send it to you in an email today. Moving back, let's go ahead and start with the Q&A session. Some of these questions to begin with were directed, I think, more towards Jerry's presentation, but I suppose either one of you could step in and be fine. All right, first question. Must the low water cutout or gas pressure high-low be a discrete switch, or can redundant transmitters be used?
They can be a discrete switch or transmitters. In the industry today, more people are going to transmitters rather than independent switches because you have a live signal at all times. Or with an independent switch, you may test it, and maybe a short time later, due to vibration or some other time, it may not be effective. You can also see very easily when your logic solver where the set point is, and it's not as easy, if it's not impossible, for your operating people to get in and change it, or if it's a switch somewhere, there are usually adjustments on the switches that the operators could bypass it easily. So the tendency is to go towards transmitters rather than independent switches, but you can use either one of them. Yeah, guy comment, Praveen?
Oh, no, I don't have anything else to add.
Okay, great. Thanks, Jerry. All right, moving on to the next question. Does the code require the burner management/safety system to protect against factors that contribute to furnace implosions?
Yes. There's a specific part in the NF85 code under multiple burner boilers, and also under almost all other types of boilers other than pressure boilers. In other words, if there's no induced draft fan or what we call draft control. Go ahead and repeat that question and make sure I get it right, Michaela.
Okay. Let me pull that up here. Does the code require the burner management/safety system to protect against factors that contribute to furnace implosions?
Yes, it's in Section 5 of the code, where it has all specific requirements for implosion protection, and the requirements for that is defined in the code in 85.
All right, thank you. Next question. How can we implement APC for burners? What should be our objectives?
What do they mean by APC? I can't answer it because I don't know what they mean by APC. Are you aware what that might be, Praveen?
I don't know if he means advanced process control. I don't know.
Okay, assuming.
Yeah, all I see is APC. Maybe we'll go back to that question
Go ahead and ask it again, and assuming that's what it stands for, let me take a crack at it. Go ahead and repeat the question again.
How can we implement APC for burners? And then it was what shall be objectives. It was like what should be our objectives?
I guess the only way I can answer that, which may not be a very good answer, it's going to depend on the kind of system you got, whether it can, what you mean by advanced process control. Is it what kind of control you use in that particular system, and whether you can, for example, is it automatic or cascade control, which are the types of control, or is it manual control? So in some cases, in particular on boilers, you can get better operation if you put in a cascade control than an automatic control. That's part of what I discussed, maybe not the right place to bring up in my course. What are the modes of control and when are they properly to be used? But the answer is yes. In advanced control, if your system has that built in, you can use that very effectively.
Great, thanks. The next question is boiler startup and shutdown should always be considered as safety function?
Yes. Part of your safety system, part of the requirement for the safety system is to monitor the system during all startup, operation, and shutdown conditions.
Okay, thank you. Next question. What is the sequence that should follow when the boiler trip manually? Sorry, I know some people, English probably isn't their first language, so I'm trying to read this the best way I can. But what is the sequence that should be followed when the boiler is tripped manually?
It's going to depend on the requirements of your boiler manufacturer, but the main thing it has to do immediately, and the first step it has to be done, is shut off all fuel to the boilers. And also, under trip conditions, unless a faulty of a fan, your fans need to keep on running. That's the second step. So when you trip, you shut off all fuel and keep the fans running. I hope that answers that question.
All right. The next question is, please advise some in-depth how to tune PID loops around the fuel/air. For example, method of tuning rule.
Well, there's a number of methods out there. One of them is one that's been around for a long time. That's a Ziegler-Nicholas method. And there's another one that's out there that's more prominent, and maybe you can help me with a name. I'd slip my mind right now. That's a tuning concept that's been more popular today. I can't think of it off the top of my head, but one of the advantages of this new system is the fact that you can prevent overshoot. But can you remember the name of that system?
Is it fuzzy logic or AccuTune?
What did you say?
Is it fuzzy logic or AccuTune?
No.
No.
Keep going. I'll try and see if I can remember it while we're going through this. But I can't think of the name of that tuning concept right now. If the person will send that question to me, when I can think of it or get back to it, I can send it to you, Caleb, and you can send it out to everybody. I just can't think of it what the name of that particular system is right now.
Okay. All right. Thanks. And we'll be giving everybody the contact information for the presenters. Oh, it's right here on the screen. If you want to contact them directly, there is their email address, so you can ask your questions if they weren't able to get to it, or you need to talk about something more in depth. Okay. So our next question here. There may be some requirements stipulated by NFPA 86, such as yearly inspection of safety interlocks, which are not necessarily required according to IEC 61511, because IEC 61511 may say that a particular safety interlock may only require a proof test every 3 years. What are your thoughts?
Well, my particular thoughts is I think it's a good idea to do them once a year. That, again, the committees are different. Each type of boiler in the 85 code is individual people. The 86 code are totally independent people. Those are on 85. So each of them may have different opinions about different things. But my personal preference is you test everything at least once a year. As I mentioned earlier, we had our system set up so that you could test online by bypassing it for a short period of time so that you could do it once a year. So we would do our testing throughout the year instead of taking at a shutdown to do all the testing at one time. You could do it on a regular basis throughout the year. Depending on your manufacturer, your insurance company, or your plant, you should be able to design a system that do it more often than that, but I certainly recommend at least once a year.
Okay, thank you. Next question. Do NFPA 85/86 force us to use redundant I/O card?
They don't. Praveen, you can probably answer that better than me. As far as I know, they don't require any redundant cards.
Yeah, that's right. As far as I know, they don't ask for redundancy at I/O levels, but usually they mention about redundancy at the CPU power supply and communication levels, but not necessarily at the I/O levels.
Well, one of the ways some of the systems address it, I'm not sure about your system, when that signal comes in, there's a 2 out of 3 voting, particularly with multiple field devices. You do 2 out of 3 voting.
Right. So, yeah, we do have the capability of 1 out of 2, 1 out of 3, 2 out of 3 voting as well, so that you can ensure the signals that come in.
Okay. Thank you, gentlemen.
I think I was able to recollect the tuning method. Was it the Cohen-Kuhn method?
No, that's not it.
Okay. Are we ready to move on? Okay, so any guidelines/suggestions for existing BMS system that is in service since last few years and is not designed as per ISA 84 requirements?
I'm not sure I understand that question. Answer it again. Ask it again.
Any guidelines or suggestions for existing BMS system that is in service since last few years and is not designed as per ISA 84 requirements?
None that I'm aware of.
Okay. All right. Well, let's move on to the next question. What is the largest allowable response time of the operators when the alarm popped up?
That is not defined to my knowledge in any of the codes.
What is the minimum standard purge time for any boiler regardless of the type/kind?
The purge time depends on the type of boiler. For single burner boiler, there is no. You have to have 8 volume air changes, and the time doesn't make any difference. Just as long as you get your 8 volume changes, it can be 2, 3, 4, 5 minutes, whatever that takes. On most other boilers, particularly multiple burner boilers, you have to have at least 5 air changes in 5 minutes. And so you have to have 5 air changes for at least 5 minutes.
If the BPCS is the initiating cause of a failure, can the BPCS also be claimed as a layer of protection?
I think you can probably answer that better than I can.
Okay, can you repeat the question again?
Sure. If the BPCS is the initiating cause of a failure, can the BPCS also be claimed as a layer of protection?
Well, your BPCS is always designed in such a way so that it can prevent any kind of incidents that come your way. But if your design itself is wrong, then that goes back to Jerry's point, where many of these incidents happen because of improper design. So, having a very reliable BPCS with a designer who does not design it as per the standards would still not help you. So, a basic process control system also has to be designed to operate in that very same way. So yes, it would still be considered as an independent protective layer, because it's normally designed to prevent any kind of process disturbances and to keep your process variables within your set point values. I hope I've answered that question.
I just got the answer for the other Ziegler-Nicholas. Then the other common approach is called lambda tuning. L-A-M-B-A, lambda tuning.
Okay.
Okay, and this question is also for Praveen. With the fast-growing digital and firmware technology, do you think that in one day we can just have a single system for both BPCS and SIS? What are the SILs of the SIFs on the spaceship, submarine, and commercial airplane that Honeywell have been handling with?
Oh, that's an interesting question. That's quite a bit beyond what probably I would know about regarding the sales of the submarines and things like those. But having one system, the first half of the question, having one system handling the BPCS and the safety instrumented system. I mean, I think technology is advancing, but then again, as Jerry mentioned, there are a lot of risks in having one system performing both the activities, because as you design the system, you need to ensure that when you have a common system doing both the things, how would you handle your online configuration, your maintenance, your testing activities, and will any of these modifications on your basic process control system cause a shutdown in due to which your safety system would actually shut down or bring it to a safe state, whatever it is. But even if your operations are shutting down, it can mean a lot of losses in dollars as well. So, as you design this thing, there are various things that need to be considered. But although technology is moving far ahead, but there are a few risks that always need to be considered. I think Jerry very well mentioned it from various parts of the standards, especially ISA 84, where if we can find a very effective way to keep the BPCS and SIS totally separate, even while making those configuration changes and any modifications that are there, I think it is still possible.
Thank you, Praveen. The next question is, what is the SIL level of a typical large utility boiler?
Well, as I mentioned earlier, large utility boilers are typically considered level 2. Some people have gone so far to say the drum level, because of the real risk value of a low water causing a rupture too, you might consider that as a SIL 3, but my experience has been that that's not the case. The only boilers that I've worked with or aware of that do hit SIL 3 are the black liquor recovery boilers, which is a very hazardous process for recovering the chemicals from a pulping process. There's lots of very severe explosions with them, and some of those areas in that can be SIL 3. But almost every other utility boiler we have in the industry, SIL 2 is more than adequate, on my experience and being all these committees.
Thank you, Jerry. Our next question, and I think this was sent during Praveen's presentation, so I think this may be directed towards him. They said, as you said, many in industry think that a BMS is SIL 2, so they don't do a good risk analysis. I believe this is a mistake. In the company I was with, we did LOPAs, LOPAs, on our fired equipment. We found that 99% of the time, we found that we typically needed 1 SIL, 3 SIFs, typically either LL water level on small fire tube boilers or flame detector on large fireboxes. All other SIFs were typically required to be SIL 1. P.S. That company had a risk tolerance of no more than 1 fatality in 10,000 years, which I believe is typical for large companies. I'd like to hear your comments on this.
So Jerry, you had initially mentioned about the standards, leaning more towards SIL 2, right? So before I just answer this question, has that always been a a norm that all the boilers would require SIL 2 without an analysis, or is that not the case? Because as far as I understand, an analysis, a safety or hazard analysis usually is done. But from your experience, do you think that this is not done, or it is done? I think we can have a discussion over here on it.
This is not done, to my knowledge, in big utility boilers. Now I'm touching on a very touchy subject, pardon the expression. S84 recognized that NFPA available in their document. It wasn't until this past one that NFPA even recognized that 84 exists. The reason for this is the big utility companies feel very strongly if they follow the NFPA code 85, they don't need to do a risk analysis, other than some feel the sealing for such as black liquor recovery boilers or drum level, you might consider SIL 3. But in general, they think as long as you follow that, and one of the other roles I have in industry is troubleshooting and defining causes of boiler explosions. And all that I've known about or been a part of, the explosion was never a result of, as long as they followed the code. All of them were a result of the code not being followed was an issue. That's been my experience.
Okay. And again, like as I mentioned during my section of the presentation, that your SIL level is always determined based on what is your current risk and what is the acceptable risk. So if your basic process control system is already very well designed, keeping most of these risk criteria into account while the design was being made, obviously your risk reduction that's required on that particular system would also be lesser. So your SIL ratings for those SIFs, there's every possibility that, even though normally for a BPCS, normally for a boiler, after doing an analysis, you come to the conclusion that it's a SIL 2, but probably a very well designed BPCS might see a lower risk reduction factor and thus looking for a SIL 1. So as you mentioned, the previous company that you worked with were risk averse, and probably they had very good engineers who had very good designs on their process control system, thus having a lower risk reduction factor and thus having a lower SIL level. So that could very well have been a possibility. Couldn't that be the case, Jerry?
Yes.
Okay.
Again, the following the NFPA code, one of the other reasons why utility companies are, I shouldn't say against, but don't want to get committed to 84, to do all those calculations on all the devices that are listed in the NFPA code as requirements for each type of boiler would be a very expensive process. So that's why they pretty well, I'm speaking pretty much my own experience, and when we meet in the next week or two, I'll talk with some of these people about this. But it should be so expensive for them to do it that they want to make sure that it does not become a requirement for boiler manufacturers to have to follow 84 and determine SIL levels on all the equipment, that they can pretty well define it as being satisfied if they meet what's mentioned in 85 for boilers. Same thing goes for 86 and 87, which is heaters and other process equipment.
Thank you, gentlemen. That was very thorough. Sorry for jumping around here. I'm just going in the order as they came in. So the next question is, you mentioned that we should look for a system that we can make online edits. Does NFPA 85 state that online logic changes are not allowed?
The answer to that question is yes. That the NFPA 85 says online changes are not allowed. However, when I was working very heavily, when we first came out with the PLCs or logic solvers, this question came up. And one of the companies I was working with was designing a system that you could not make changes. Myself and a number of other companies, I think there were 4 or 5 other major manufacturers of chemical processes and so forth, made the statement that when we don't shut down every 3 or 4 or 5 years, whatever it is, we need to make changes online. So most companies have designed a safe way, I encourage that safe way of doing online changes, but the code specifically says you should not make online changes. This is, you have to work out with your insurance company or your individual company is what they agree to. I don't know whether you are with that, Praveen.
Yeah, I mean, I would definitely agree with you on that, especially with the example that you gave, where most of them don't shut down for a longer period of time. And to be able to probably add a bypass or a different valve or something like that, they would require some kind of capability to, to make changes in a safe way, as you emphasized again over there. So that was very well put out.
All right, our next question says it's an important question. So, offshore application, assume that the input/initiator, i.e. the sensor, is located on a platform physically 5 miles far from a logic solver, PLC, which is located on another platform per experiences with Honeywell. Which communication/link is at highest availability/reliability? Please forgive me, Modbus or Foundation Field Bus, or what protocol?
For me, I don't think I can answer that question because I don't really know anything about offshore equipment. But I guess the main thing I need to comment on is anything that's safe like that, and I have no idea how they do it. But at this particular time, as far as I know, you cannot have any wireless communications. That has to be direct wired. So which other systems you use, I don't think it makes any difference as long as it's not a wireless connection.
Yeah, I mean, that is what I was going to say too, that I don't think that any specific protocol is specified over here. But it doesn't say that it has to be Modbus or Foundation Field Bus or HART. As long as the signals are hardwired into the safety system. So, to my knowledge, too, there is nothing specified as a specific protocol. I would like to know more about it if there is something specified like that.
All right. We have time for just one more question, and let's see. This question is, what is non-interfering process I/O?
Okay, so that is part of my presentation over there. So what it showed on that particular architecture diagram was that you could actually you could have a separate rack where process IOs or process signals can be taken in, and we have designed the system, the HC900 system, in such a way that even though these process signals would be hardwired and it comes into the process worksheets, which are segregated and separated on the software end, you would not be able to transfer any information like the signal tags or the variables across from the process side to the safety side. Although, if there's a hardwired signal that comes in from safety, the safety signal can always write to a process signal, where it can send data across to the process side. But there is no interference whatsoever from the process side of the worksheet to the safety worksheet. So that is what that diagram meant, where it said that it's totally non-interfering, because if you're going to have some combined solution, maybe not for a BMS system, but for some other critical application, and you just have probably 5 or 10 IOs or maybe 20 process IOs, and you've got maybe 200 critical IOs, which are mainly for safety applications, you might think against having a separate process system to really handle just those 10 or 15 process IOs. So in such a scenario, we have made that provision within our system so that these process signals can come in. And on the other end, we have also ensured that it will never interfere with the safety system because that is one of the requirements of the code that nothing should ever interfere what the safety system is doing. So that is what we have tried to achieve within the design of the product too.
Great, thank you, Praveen. Appreciate it. Unfortunately, we're out of time here, and I know we have a lot of questions remaining. But please, take down the presenter's contact information, contact them directly. I'll also be sending their contact information in an email shortly after this webinar, so just be on the lookout for that. I already went over Automation Week, but just to remind you, that is next week. And if you missed any portion of this webinar, or if you would like to watch the recorded version, we will be emailing all registrants a link to the recording, along with additional links and resources for supporting information, including ISA training courses on burner management systems that are offered year-round. So be on the lookout for an email from me in the next couple of days. And we're always looking for ways to improve our webinars, and we would love to get your feedback. So following this webinar, I'll be sending everybody an email with a link to take a short survey about this webinar. So please just take 2 minutes to fill it out. Your feedback is much appreciated, and we'd love to improve our webinars as much as we can.
I would like to make this comment, and Praveen would probably want the same thing. When you submit a question, be sure to let us know it's coming from this webinar, because if things come through with just a name on, I don't have any idea what it is, because I get many, many messages coming in. I delete them, so make sure you're referencing the webinar. And also, if anything that comes in within the next day or two, give me a time to correct it. I'm receiving emails, but I'm having trouble replying back and answering through my email system. I expect to have that fixed in the next day or two.
Great, thanks, Jerry. Oh, and also, if you would like to submit claim this webinar for a professional development hour for a PDH, I believe we can give you 1.5 PDHs for this webinar. So just contact me directly, and I can get you that. So thank you so much for everybody who's been in attendance, and we hope to see you again in one of our future webinars.